Hello everyone, welcome to my YouTube class. In this video we will see how do we check if the given matrix is an identity matrix or not. Now what is the identity matrix? Identity matrix, it should be a square matrix where all the principal diagonal elements should be 1 and non-principal diagonal element should be 0. That is what the definition of identity matrix is. Now whenever we say it should be a square matrix, that means the number of rows should be equal to the number of columns. Now here the matrix is of order 3 cross 3. We know that what are principal diagonal element? The principal diagonal elements are 1 where the row number should be equal to the column number. Now what we do? We take the each element of the matrix and check if it is a principal diagonal element, then it should be 1, and if it is not a principal diagonal element, it should be 0. It cannot be anything other than that. Now how do we take each element of the matrix? We say for the value of I starts from 0, I less than the number of rows, and we say I plus plus. This is for the row by row. And then we take each column of the individual row. How do we do it? For j is 0, we can say j less than r, or we can say j less than c, because r is equal to c, and I say j plus plus. Now if it is a principal diagonal element, it should be 1. If it is a principal diagonal element, it should be 1. How do we know that it is a principal diagonal element? We say if the value of I is equal j, that means it is a principal diagonal element. Now if it is a principal diagonal element, it should be 1, and if it is not equal to 1, can it be a what do I say, identity matrix? Say for example it was 11. Can it be identity matrix? No. Therefore I check and if it is a principal diagonal element and a of ij is not equal to 1, that means a of 0 0 is 11, 11 not equal to 1 true, that means it cannot be an identity matrix. And if it is not an identity matrix, what we do? We return 0 then and there, because there is no point in checking the other elements. There is no point in checking the other elements. Suppose if it is 1, now the value of I is 0 and the value of j is 0, that means it is a principal diagonal element. I equal j, yes. A of 0 0 is 1, 1 not equal 1 is false. Therefore you do not do return 0. You do not do return 0. That means till this point of the time we are under the confirmation that it may be identity matrix. It may be identity matrix. Now you say j plus plus, the value of j will become 1. Now 0 equal 1, no, that means it is not an identity, it's not an principal diagonal element. Now if it is not a principal diagonal element, how do we know that it is not a principal diagonal element? We say else if I not equal j. Now I not equal to j says that this particular element is a non-principal diagonal element. And what should be non-principal diagonal element? It should be 0. Suppose if it was 10. Can it be a principal? Can it be an identity matrix? No. Hence I write and a of ij is not equal 0. It cannot be an identity matrix. Hence what do we write? We say return 0. This is the end of this for loop, and this is the end of this for loop. Now I not equal j, yes. A of ij is 10. 10 not equal 0, yes, and you say return 0, saying that it's not an identity matrix. If it is identity matrix, we will return 1. If it is not identity matrix, we will return 0. Now see here, suppose if it is 0, I not equal j, yes, a of 0 1 is 0, 0 not equal 0 is false. Do not execute this. Again you say j plus plus, the value of j will become 2. 2 less than 3, yes. 0 equal to 2, no. Since if is false, come to else if. 0 not equal to 2, yes, it means it is not a principal diagonal element, and if it is not a principal diagonal element, it should be 0. A of 0 2 is 0, 0 not equal 0 is false. Do not execute this. Again you say j plus plus, j becomes 3, 3 less than 3 is false. You come out, that means as of now the first row corresponds to the identity matrix. I am saying the first row corresponds to identity matrix. The second row may or may not. Again you say I plus plus, the value of I becomes 1, j starts from 0. 1 equal to 0, no. 1 not equal to 0, yes. A of 1 0. Now what is A of 1 0? 0. 0 not equal 0 is false. Do not execute this. J plus plus j becomes 1. 1 equal to 1? Yes sir, 1 is equal to 1 because it is not, it is a principal diagonal element, and A of 1 1 is what? 1. 1 not equal 1 is false. Since if has false, come to else if. Now what is the value of I? 1. 1 not equal 1 is false. Do not execute this and you say j plus plus j becomes 2. 1 equal to 2? No. 1 not equal to 2? Yes. A of 1 2 is 0. 0 not equal 0 is false. That means till second row the matrix is identity matrix till second row. Now I have to check the third row as well. Again we say I plus plus I becomes 2 and j starts from 0. 2 equal to 0? No. 2 not equal to 0? Yes. A of 2 0 is 0. 0 not equal 0 is false. Therefore you say j plus plus j becomes 1. 2 equal to 1? No. 2 not equal to 1? Yes. A of 2 1, and what is A of 2 1? 0. 0 not equal 0 is false. Again you say j plus plus j becomes 2. 2 equal to 2? Yes sir. A of 2 2. What is A of 2 1? 1 not equal 1 is false. Since this if is false, come to else if. 2 not equal 2 is false. Do not execute return 0. Again you say j plus plus j becomes 3. 3 less than 3 is false. You say I plus plus I becomes 3. 3 less than 3 is false. You come out of this for row. That means you have checked all the rows, and all the rows corresponds to the identity matrix. And if it is an identity matrix, what shall I return over here? I shall return 1, saying that it is an identity matrix. Is that okay? Now we will put this in the form of a function. If it is an identity matrix, we return 1, and if it is not an identity matrix, we return 0. This is how, very simple, you take each element of a matrix. And how do you check it is a principal diagonal element? Row number is equal to column number 0 0 1 1 2 2. How do you check it is not a principal diagonal element? Row number is not equal to column number, and you check it is not a principal diagonal element. And principal diagonal element, if it is not equal to 1, it cannot be an identity matrix. Non-principal diagonal element, if it is not equal to 0, it cannot be an identity matrix. Therefore you return 0, and when you come out of the loop, you return 1, saying that boss, it's an identity matrix. Please pause the video over here and try to write the program yourself. Thank you. Let us see how do we write the code to check if the matrix is identity matrix or not. Now for the matrix to be identity, it should be a square matrix first. It should be a square matrix first. Now how do we write? Hash include and all, and you have to write the appropriate prototype for read matrix and display matrix, as well as we will write one function to check if it is identity or not. Let me say here int main. Let me say here int main. What is the input for this question? The input for this question is a matrix. Therefore I say int a of row cross column, and if I say row cross column, you have to say hash define row 10, hash define column 10, or any other values. And we need the number of rows and the number of columns C, and we say printf enter order of matrix. Printf enter order of matrix. And here we read the value of R and C. We say scanf %d ampersand R ampersand C. Say for example, the value of R is 3 and the value of C is 2. Can I check it is identity matrix or not? I cannot check. Why? Because it's not a square matrix. Hence, I need to check over here if R is not equal to C. If R is not equal to C, we say printf matrix should be square. I say here matrix should be square. If matrix is not square, we cannot check if it is identity matrix or not. And here I say exit 0. Exit means what? You stop the code then and there and say hash include stdlib.h, because if it is not a square matrix, what do I check if it is identity matrix or not? It's not possible. Assume that the value of R is 3 and C is also 3, that is the order of the matrix is 3 cross 3. 3 not equal 3 is false. Do not execute this. That means matrix is square, and if matrix is square, what I need to do? I need to read the matrix. Therefore, we will write one function called as read matrix. Which matrix we want to read it? A of what order? R cross C. Of course, R is equal C. You can say R cross R comma R as well, or C comma C as well. In general, we say R and C. Suppose the matrix red is this. Suppose this is the matrix red. Now, what I want to do with the red matrix, I want to check it is identity matrix or not. Let us write one function called as isIdentity. Let us write one function called as isIdentity, which will give answer as 1 if it is identity matrix, and it gives answer as 0 if it is not identity matrix. Now, which matrix I want to check identity or not? A of what order? R cross C. And what it is giving us the answer? 1 not 0. And 1 not 0 is of what data type? Yes, 1 not 0 is of what data type? Integer data type. And let me store the answer in some variable called as say x. Answer in some variable called as x, and I declare a variable x. Now, if the value of x is 1, what kind of matrix it is? Printf identity matrix. Printf identity matrix. If the value of x is 0, 0 equal 1 is false, then we say else not identity matrix. Hence we say not identity matrix. And let us write the function is identity. Now, what is the return type of the function? It is integer. It returns 0 if it is identity, 1 if it is not identity. What is the function name? Is identity. What is the first parameter here? A, integer 2-dimensional array, integer A of row column. What is the second parameter? R, the number of rows. Third parameter is the C, the number of columns. Is C, the number of columns. Now, how we check if it is identity or not? Already I said we go to each element of the matrix. If it is principal diagonal element, how do we know it is principal diagonal element? I equal j. And if it is not equal to 1, it cannot be a identity matrix. Therefore, we say int ij. We go to each element of the matrix. For I is 0, I is less than r, I plus plus. And what do I write over here? For j is equal to 0, j is less than c, j plus plus, j plus plus. Now here what I need to do? I need to go to each element of the matrix. And how do we go to each element of the matrix? A of ij. How do we go to each element of the matrix? We say A of ij. Okay, just a moment. Okay, here I write if I is equal j, that means it is a identity, it's a principal diagonal element, and A of ij, if it is principal diagonal element and principal diagonal element is not equal to 1, and principal diagonal element is not equal 1, what do I write over here? I say return 0. Suppose if it was 11. I equal j, yes, A of 0 is 11, not equal to 1 is true, return 0, it will return 0, x is 0, 0 equal 1 is false, and it says not identity element. Now if it is 1, I equal j, yes, A of 0 is 1, 1 not equal 1 is false, and I have to check for non-identity element, non-principal diagonal element as well. Already I explained, I not equal j, and A of ij not equal to 0. A of ij is not equal 0, then also it cannot be a identity matrix, and what we do, we return 0. Now 0 not equal 0 is false, j plus plus 1, 0 equal 1 is false, 0 not equal 1 is true, A of 0 1 is 0, 0 not equal 0 is false, and so on it does. At the end, if what I do, I say return 1. Already I explained this logic. It means it is a it's an identity matrix, and return 1 means the value of x will be 1, 1 equal 1 is true, and it says it is an identity matrix. This is how we check if the matrix is identity or not. Again, this we are going to use it in orthogonal matrix, because orthogonal matrix is A multiplied by A transpose will give you identity matrix. Thank you friends for watching this video. Please pause video over here and you may make the appropriate notes. Please like this video, subscribe to my channel and share the channel with your friends. Thank you.